I am going to present about experiment 4, cells recovery based on sedimentation and centrifugation principle. My group members are Chongqi Chong, Guo Wangyu, and Wang Xiuxia. The objective of this experiment is to separate the yeast cells from broth based on the concept of sedimentation and centrifugation. Sedimentation is tendency for particles in suspension to settle out of the fluid. Cells are separated based on different gravity and concentration gradient. Rate of the separation mainly depends on the particle size and density. Centrifugation is the separation of molecules having different size and density by spinning them in solution in a centrifuge rotor at high speed. Micromolecules move through a liquid under the influence of a centrifugal force. The results are influenced by the density of sample and solution, temperature of viscosity, distance of particles, displacement, and rotation speed. The materials used in this experiment are yeast solution, distilled water, burette reagent, and sodium hydroxide. The apparatus used are settling tube, cuvette, spectrophotometer, and centrifuge. The procedure of the sedimentation is: first we prepare 20 grams per liter yeast of suspension and then pour 40 ml of the yeast suspension into 5 different setting tubes. Next, allow the 5 samples to stand for 5, 10, 15, 20, and 25 minutes. After that, transfer the supernatant into the empty bottles carefully. Lastly, we proceed to the burette assay and analysis the supernatant by spectrophotometer. The procedure for the centrifugation is quite similar to the sedimentation. First, pour 2 ml of the yeast suspension into the centrifugal tubes, and then centrifuge at 5 different rotation speeds, which are 1500, 2000, 2500, 3000, and 4000 rpm, and then transfer the supernatant to the empty bottles after the centrifugation. Lastly, proceed the experiment with burette assay and analysis the supernatant by using the spectrometer. Results and discussion. For the sedimentation, the results demonstrate the absorbance at 332 nanometer at 5 different times. This is a graph of absorbance versus time. From the graph, we can see that the optical density of the sample decreased gradually when the time increased. This shows that the sedimentation effectiveness increased when the time increased. It means that the tendency for each particle in suspension to settle out from the fluid is increased with the sedimentation time, the supernatant clearer. For the centrifugations, the results demonstrate the absorbance at 540 nanometer at 5 different rotation speeds. This result is then plotted into the graph. This graph shows the absorbance versus RPM. From the graph, we can see that the optical density of the sample shows decreasing trend with increase of the centrifuging speed. This shows that the higher the rotation speed, the stronger the centrifuging force added, hence shorter time is needed for separation process to complete. The decrease of the optical density values indicates the solid-liquid separation process was effective. In conclusion, the objective to study the basic principle of solid-liquid separation based on the sedimentation and centrifugation technique was achieved. The optical density for sedimentation dropped from 0.74 to 0.46 after 25 minutes. The optical density for centrifugation method was 0.365 at 1500 rpm, which was lower than that in sedimentation. Hence, we can say that centrifugation method can perform cell separation from the medium faster than using sedimentation method. That's all. Thank you.